Hi, I'm Rob from Microsoft Security Research.
And I'm Tom, also from Microsoft Security Research.
And today, we're going to run through an investigation involving a web shell attack. Microsoft has seen increased usage of web shells in campaigns conducted by nation-state and cybercrime actors. With web shell attacks on the rise worldwide, in this session we investigate a real-world web shell attack and how threat protection security solutions from Microsoft detect and respond to it. But first, let's take a look at threat protection security solutions from Microsoft. Microsoft's integrated threat protection suite is offered through Azure Sentinel and Microsoft Defender, which is our holistic solution for what's known as Extended Detection and Response, or XDR. Azure Sentinel is a cloud-native security information and event management tool, or SIEM, that gives you a bird's eye view across the enterprise, letting you see and stop threats before they cause harm. You can make your threat detection and response smarter and faster with AI and get an end-to-end view of your organization by easily connecting data from your Microsoft products and third-party sources. Azure Sentinel also eliminates security infrastructure setup and maintenance and scales to meet your organization's needs. Microsoft Defender delivers two tailored XDR experiences for security professionals. Microsoft 365 Defender gives you a set of connected best-of-breed solutions for your data, device endpoints, identities, and apps. Azure Defender gives you threat protection across your server endpoints, containers, network, IoT devices on the edge, and managed apps. Together, Microsoft 365 Defender and Azure Defender give you an end-to-end XDR solution for threat detection and response across your Microsoft estate in the cloud or on-prem and in other clouds. In this session, we're going to show how threat protection solutions from Microsoft can be used together to investigate a web shell attack and build out the picture of the compromise. Before we dig into the investigation, I'm going to hand it over to Tom, who will talk a bit about web shells and how they're used in attacks.
Thanks, Rob. Let's start by having a look at what a web shell is and how they've been used in some real-world scenarios. A web shell is a script that is deployed to a web server by an attacker through an exploit or server misconfiguration. Web shells are designed to be executed from a single file, and they usually have a small file size. After uploading a web shell, the attacker will normally rename the file so that it blends in better with the files already available on the system. All of these steps are taken by an attacker to help keep their web shell under the radar and remain slightly more covert. There's a huge variety of web shells available out there, written in a whole range of different languages. In most instances, attackers will use web shells that they've downloaded from a publicly available repository. Web shells provide a GUI, an interactive command line piece of functionality that the actor can use to interact with the server that they've compromised, conduct reconnaissance activity about the server and the network environment that it's in, and even pull additional malicious files to aid them in their campaign later on. In the diagram that you can see on the screen, we can see that a simple HTTP request to the web shell hosted on contesto.com results in a command being executed at the command line. Here you can see the actor has executed ipconfig, who am I, and system info. So they're probably doing some reconnaissance to figure out where they are and who they are. Now let's have a look at some real-world examples of how web shells have been used. Web shells are often used as an initial access vector by an actor. Many network configurations are set up in such a way that the external web server and the internal corporate network have some level of interconnectivity. Attackers will use a web shell as a beachhead into that internal network from that external network resource. When no physical network connectivity is present between the external server and the internal environment, actors will often use a web shell to upload additional phishing resources, which they'll then use to spearfish users of that organization, using the legitimate domain name as a trust link so that the users click it and are more likely to enter their credentials. We also commonly see threat actors using web shells to facilitate command and control. Threat actors will use the web shell to download additional scripts that can be used to proxy malware communications from their victims downstream to their upstream infrastructure. Recent web shell attacks by Zinc, Gallium, and Krypton have successfully used web shells and achieved domain admin access to networks. Now I'll hand back over to Rob, who'll talk through the incident that we're going to be investigating in today's scenario.
Thanks, Tom. In this session, we're going to investigate an attack that has already taken place from the perspective of the SOC. The attack is outlined on the diagram on screen and reflects the two types of web shell usage that Tom just covered across a hybrid environment of on-premise and cloud. In step 1, an attacker exploits a vulnerability in a public-facing on-premise SharePoint server. There is a patch available for this vulnerability, however it has not yet been applied to the server in question, leaving it vulnerable to attack. They leverage that vulnerability in step 2 to install a web shell for persistent access and use it to execute several malicious commands in support of their aims. Using the shell in step 3, the attacker moves laterally from the SharePoint server into the corporate environment, where they extract credentials. Finally, in step 4, the credential material is copied back to the SharePoint server and downloaded by the attacker. One of these compromised credentials has contributor rights to the organization's Azure subscription. In step 5, the attacker uses this credential to remotely install a web shell on the App Services website, Contoso Online. In step 6, this web shell is used to download and install a malicious Word document on the site for use in a later mail-based attack. Next, we will see how Microsoft threat protection products will be used by the SOC to investigate this attack and build out the picture of the compromise. The SharePoint compromise and resulting incident will be shown in Microsoft 365 Defender. The Azure App Services compromise we'll see show up in Azure Defender, and we'll use Azure Sentinel to investigate the alerts and incidents from each of these, using additional log sources to find new insights into the attack. First, we will show the incident generated by the SharePoint compromise in Microsoft 365 Defender. Here we can see the overview page of the incident that has been given the name Web Shell Attack, followed by reconnaissance, credential theft, and lateral movement. Incident names in Microsoft 365 Defender can be automatically generated based upon the types of activities conducted in the attack. In the top left corner, we can see that this incident contains activities that cover 6 different MITRE attack categories, including initial access, credential access, and command and control. We see the entities that have been implicated in the attack in the scope section, 2 machines including the SharePoint server, and an account that was used to move laterally between the two. Let's take a look in more detail at the alerts that make up this incident by clicking on the Alerts tab. We can see 16 alerts in total here for the incident, coming from EDR, AV, and Azure ATP detection sources. These cover a range of activities such as web shell installation, exploration, and credential access. By having the alerts grouped from these different products into a single incident like this, we make the task of triage easier for the SOC by giving them one set of activities rather than 16 individual alerts, which may have ended up assigned to different analysts, making the job of piecing the attack together more difficult. We can dig down into the detail to understand why these alerts have been assigned to this incident by looking at the link by reasons. Let's take the sensitive credential memory read alert as an example. Here we see an EDR alert for credential theft from the Alsace process. In the link by reason, we can see that this was included in the incident because it happened on the same machine as a number of the other alerts, and the file pd64.exe, which was used to perform the memory read, was also implicated in the other alerts. There are many possible link by reasons for alerts that cover a variety of different entity types, such as URL, IP address, user, etc. Now let's take a look at the evidence associated with this incident. In addition to the alerts, the evidence associated with an incident is also collected in one place. Here we can see a number of processes associated with the attacker activity, such as Alsace, PowerShell, and WMIC, as well as pd64.exe, as seen in the link by reason in the previous alert. Let's filter to show only the files that were involved in the attack. In here, we see a number of writes to web script files, global.aspx and fonts.aspx. These have been identified as suspicious. They are located inside the web accessible application directory of the SharePoint server and are the web shells that were installed as part of the attack. These files form the basis of the next phase of our investigation. Next, we're going to take the incident we have just shown and correlate it with a third-party log source in Azure Sentinel to gain additional insights into the attack. The organization uses a web application firewall, or WAF, which records the details of each web request made to the SharePoint server, including the malicious ones used by the attacker to execute commands through the shell. These request logs are also connected to Azure Sentinel, and we can use them to correlate with the alerts from the Microsoft 365 Defender incident and gain extra insights. Because the web application firewall sits on the edge of the network, it has unique visibility into the detail of malicious requests made to the attack server. There are a ton of useful insights to be gained by correlating web request data with web shell alerts. However, in this scenario, we focus on the source IP address of the attack, as it is the most actionable for our investigation. As we land in the incident view inside Azure Sentinel, we can see that the web shell incident for Microsoft 365 Defender has already been correlated with WAF data. This is thanks to an analytic we have set up in the environment that does this for us automatically. It uses the time of the alerts, combined with the suspicious web script file names and locations extracted from the incident, to pull out linked web requests that were made by the attacker and enrich the alerts with the details. Let's click Investigate to take a closer look. In the investigation graph, we can see an entity-focused view of the attack and its insights. If we expand our SharePoint server node, we can see the related alerts from the Microsoft 365 Defender incident. These are the alerts we have correlated with the web request data. Linked to the incident, we can see we have two URL entities, one for each of our web shells, fonts.aspx and global.aspx, and a new IP address entity. This is the IP address of the attacker seen using the web shells in our WAF logs. We'll come back to this graph later, but for now I'm going to hand it back to Tom, who will take you through the Azure Defender part of the investigation.
Thanks, Rob. Now let's take a look at the next stage of the attack, where the attacker will be targeting some of our cloud-based infrastructure. As Rob covered earlier, the attacker now has legitimate credentials that can be used against the cloud components of our network. In this example, Contoso is using Azure App Services to host the web application called Contoso Online. The attacker in our scenario uses the compromised credentials to access the Azure App Services management portal. This portal allows the attacker to download a publishing profile which contains Contoso Online's FTP username and password. As seen in the diagram, the attacker uses these credentials to access the server, upload a PHP web shell, and stage a malicious document for a later spear phishing campaign. Above the install web shell and stage malicious document icons, we can see that an alert is raised by Azure Defender. This indicates that these malicious actions have been detected by Azure Defender. Azure Defender uses data from various Azure log sources to correlate events and detect potentially malicious activity. We'll take a deeper look at those alerts in just a moment. The alerts that were generated by Azure Defender are consumed by Azure Sentinel. Azure Sentinel also consumes logs from Azure Activity. This will show the attacker stealing our publishing profile. Before we correlate these logs in Azure Sentinel, let's take a look in Azure Defender at the alerts that have been generated. We can do this by going to the Azure Security Center. Here we are in the Azure Security Center Security Alerts Overview page. As you can see, a couple of alerts have been generated as the attack on Contoso Online took place. Let's take a look at PHP file in upload folder first. This alert is generated when a PHP file is uploaded to a known uploads folder. In this case, config.php, the attacker's web shell, has been detected. We can also see in this alert the IP address the attacker used and the user agent. This confirms that the attacker matches what Rob saw in our WAF insight earlier, as it's the same IP and the same user agent. Let's go back to the security alerts overview page and then take a look at the phishing content hosted on Azure Web Apps Alert. This alert is generated when a spear phishing email is sent and it is detected by Office 365. In this case, the attacker has included a link in their email that is hosted on the Contoso online web app. We can see the link points to COVID-19 bonus.docx. The fact that we have this alert means that the attacker has likely already sent a spear phishing email to some of our users. Both of these alerts will have been passed through to Azure Sentinel. So let's go back to our Azure Sentinel investigation graph and take a look at these alerts a little bit further. Now we've had a look at the alerts in Azure Security Center, let's go back to our Azure Sentinel investigation graph and have a look at how those alerts appear within our investigation. Here you can see that we've landed in our Azure Sentinel investigation graph. We can expand the attacker IP nodes associated entities, and we can see the Azure Defender alerts that are associated with the attacker IP address. These are the same alerts that we saw within Azure Security Center. These are already correlated because the attacker IP address that we used on the on-premise attack Rob investigated earlier is the same as the IP address the attacker has used to attack our cloud infrastructure. We can further expand the entities associated with the ASC alert to see the resource affected and the URL that resulted in the alert being triggered. As I mentioned earlier, the attacker compromised a legitimate Azure account and used that to download an Azure Apps Publishing profile. The Azure activity log contains information about the authenticated actions taken on the Azure subscription. While we explored the investigation graph, another analyst has executed a hunting query against Azure activity to identify what actions the attacker IP address has taken on our subscription. The analyst has bookmarked that query and their findings, and they've attached them to this investigation. We can expand the IP entity, hover over more, and then click bookmarks to load the bookmark into the graph. Clicking that entity will load a blade on the right-hand side with the bookmarked information. We can see on the right the query that was executed by the analyst and the result that they've chosen to bookmark. Here you can see that they've looked for the attacker IP address in Azure Activity, and they've identified that the Gemma G account has probably been used to download the publishing profile. We can see there that the operation entitled Get Web App Publishing Profile has been executed by the attacker using that account. We can further expand the bookmark to add its entities to our investigation graph. Here you can see the Gemma G account has been added to our investigation, and some links have been formed between the attacked resource and the attacker IP address. Clicking on the Entity tabs to the right shows all of the entities that are part of our investigation, including Gemma G, the attacker IP, and some of our attacked resources. With these entities as part of our investigation graph, we can now execute an Azure Sentinel playbook over this investigation to respond to the attack. Let's take a look at a playbook that we created earlier that allows us to respond to this attack. Here we are in the Alert Playbooks overview page within Azure Sentinel. We can see the Respond to Web Shell Attack playbook that we created earlier. Let's go ahead and execute that playbook to stop the attacker in their tracks. Now, let's take a look at what executing that playbook has actually achieved. We can open the designer, and this will bring up the Logic Apps Designer for this playbook. We can see here that the playbook is executed over the Azure Sentinel investigation graph. It will extract the account entities from that graph and disable them in Azure Active Directory. In this case, it will be the Gemma G account that the attacker is in control of. It will then extract the IP address entities from our investigation graph and block them in Azure WAF and also in app services. This will stop the attacker from using that same IP address to access their web shell or potentially call into any additional backdoors they may have placed that we may have overlooked. Finally, we can send the IP address of the attacker to Microsoft 365 Defender using their Indicator API.
Thanks, Tom. Next, we'll take a look at what can be achieved when insights from an Azure Sentinel investigation are shared back with Microsoft Defender security products. In the last step of the playbook, we use the Indicator API to share the attacker IP address with Microsoft 365 Defender. Let's check back in with the Microsoft 365 Defender portal to see the impact this has had on our original incident for the SharePoint compromise. Here we see a new incident containing the alerts from the SharePoint compromise shown earlier, plus a number of new linked alerts for a mailbox, marco.sellers@contoso.onmicrosoft.com, and an additional machine. The incident name has also been updated to add linked with mail campaign using Azure Sentinel Insight. Let's take a look in more detail at the alerts that make up this new incident. At the bottom of the page, we can see that we have a new alert titled Suspicious IP Address Shared from Azure Sentinel Investigation, and that it was included in this incident because of a similar IP address. If we click into the alert, the description tells us that this was triggered because a suspicious IP address was observed in telemetry. Scrolling down to the linked by reason, we can see that the suspicious IP is the same as the one just shared from our Azure Sentinel investigation. We can also see that there are 11 other alerts in this incident that are now linked because of this IP address. By selecting one of the alerts from the original SharePoint compromise, possible IIS compromise, we can see an example of these. The linked by reason in here has now been updated to include the suspicious IP address shared from our investigation. This common IP address and the knowledge that it is malicious has also caused a number of new alerts to become part of the incident, including those from a mail-based attack. Let's take a closer look at one of the alerts for the mailbox. Email messages containing fish URLs removed after delivery to get a better understanding of what went on. Inside the alert story, we can see the details of the mail message that triggered this alert. The sender, contosobenefits@outlook.com, and the subject of the mail look immediately suspicious. If we scroll to the linked by reason for the alert, we can see that it is based upon URL similarity, and that the link acting as the lure in this phishing mail is the same as the link we observed in the Azure Defender alert, COVID-19 bonus.docx. So what happened here? We saw earlier from the Azure Defender alert that the staged malicious document had been used in a mail-based campaign. A mail was sent to the victim, Marco Sellers, with a link to the malicious document hosted in App Services. The link is convincing because it is hosted on the organization's website, and the lure is tempting because of its subject. The victim clicks the link and opens the Word document. The malicious code in the document contacts our attacker for command and control. Thanks to our investigation in Azure Sentinel, Microsoft 365 Defender now knows that the IP address of the attacker is malicious, so an extra alert is triggered for the contact with the IP address. The IP address now appears as evidence in both the SharePoint and mail-based attack. The new alert from the mail side of the attack acts as a trigger that causes the two incidents to join on the common attacker IP. Knowledge that the IP is malicious gives Microsoft 365 Defender the information it needs to correlate both sides of the attack into a single incident. This one incident that now covers two previously disconnected attacks gives the SOC a complete picture of the compromise oriented around a common attacker, and this concludes our investigation. Thanks for joining us in this session as we took a look at how threat protection security solutions from Microsoft can detect and respond to a web shell attack. We investigated an end-to-end attack based across cloud and on-premise in Azure Sentinel. We used the alerts and incidents from Microsoft 365 Defender and Azure Defender, combined with first-party and third-party log sources to build out the picture of the compromise and gain new insights into the attack. Leveraging Azure Sentinel's security orchestration and response capabilities, we then actioned those insights by performing blocking in first and third-party appliances and services. We then shared the discovered attacker IP address with Microsoft 365 Defender using the Indicator API. This allowed us to connect the dots across previously disconnected attacks, revealing a new phishing phase combined into a single incident which shared the same attacker. We hope you enjoyed this session, and if you'd like to get more information on threat protection and security products from Microsoft, check out aka.ms/seam and XDR.